Good afternoon, Vancouver. I hope you can all hear me. My name is Joanna Wu, and I am the director of the Trottier Observatory at Simon Fraser University, also a member of the physics department. And with me today, we have quite a few people. We have a couple of staff, longtime staff members from the observatory, including Zena, Abby, and Kyle. And we also have several members from the Royal Astronomical Society here with us today. I'm sorry, Zena?
Oh, sorry about that. I opened the YouTube.
No problem. Okay. All right, so hopefully this is working. So we have Karambir, Haley, Scott, Ken, and Ken, who are with us from the Royal Astronomical Society. So today we wanted to look at Jupiter and Saturn, but there's a cloud right there. So we're going to look at the moon instead. So here we are looking at the moon. And hopefully, let's move it back a little bit so you can see a little bit more of the moon. In fact, I'm going to take a little bit of a longer exposure so you can take a look at the moon. We're going to try looking at Jupiter and Saturn later. Hopefully the clouds will clear, and when it gets darker, it might even look a little better. But here we go. Here's the moon. Maybe increase the exposure just a little bit more. There we go. This is the moon. So Abby, do you want to tell us a little bit about the moon?
Yeah, sure, of course. So I enjoy looking at the moon a lot because I live in an urban space, so it's very hard to look at a lot of fainter objects. However, with the moon, it's very easy to observe even if you're in the heart of a city. So right now in this here, we are looking at the Sea of Crisis. So if you can see my mouse hovering in here, this is called the Sea of Crisis.
Maybe I'll move up a little bit so that we can actually see it. There we go. Here.
So, yes, this is the Sea of Crisis. So, yeah, it's a really relatively smaller lunar maria, so it's actually quite easy to see at its earlier phase. So, Joanna, do you mind moving the moon a little bit to the middle part?
The moon. So moving towards the center of the moon, like where the Okay.
Towards the center of the moon.
Sure. Right now, because the phase of the moon is technically called the first quarter, even though it's actually a half moon. It's a quarter because it's a quarter of the way around the Earth from new moon. That's the reason why. But yeah, let's try to see where the shadow is.
Yeah, I would like to look at the Terminator line. So that's how we actually observe the craters. So actually, when you're observing the moon, it's actually best to observe at a non-full moon day, because during the full moon, the moon is too bright that it outshines all of the craters. So if you actually want to look at individual craters, you would have to look at a very specific day at the Terminator line, because the angle is just at the right angle to reflect all of the craters out. Okay, yeah, this is perfect. So, right now, you can see that we're looking at the mountain. So, moon, just like the Earth, there are a lot of plates. So, we also have moonquakes on the moon. We're looking at the mountain.
Oops.
So, moon, just like the Earth, there are a lot of plates. So, we also have moonquakes.
Haley, you gotta mute your mic.
Okay, so yeah, right now we're looking at the mountain, the Apennine Mountains. So this is the mountain that names after an actual mountain in Italy. So on the right-hand side here, this is the Sea of Serenity. And on the left-hand side, you can see this darker shade. This is the Sea of Rain. And if you can see this range of mountains in here, this is the Apennine Mountain that I was talking about. So the mountains on the moon are actually same on the Earth. They are formed by moonquakes, formed by the collision of different plates.
So Abby, do you know where the Apollo 11 moon landing was?
Oh yeah, the Apollo moon landing was actually in the Sea of Tranquility. So we have to move our frame to a little bit to the right, away from the center. So yeah, so that was actually the Apollo mission back in 1969, the first manned mission in here. And if you can see my mouse hovering over here, this is a Sea of Tranquility.
Cool. Do you know where exactly it was, or just?
I think it's around somewhere here, but I'm actually not too sure too. But it's somewhere there.
Yeah, I'm not too sure. I think I once knew this when.
I think it's more in the southern part.
So like more like down here. Down here. I think I remember it being closer to the other one, but I'm not exactly sure. I don't remember. But
Yeah.
somebody could look it up. But it is definitely the Sea of Tranquility, wherever it was in the Sea of Tranquility. It was there.
And it's actually quite a special sea to me because Sea of Tranquility, if you're looking through a pair of binoculars, it has a really rich dark gray color, which is very interesting by comparing to the colors like around it. So I really like it. It's such an interesting sea to look at.
Very cool. Thanks, Abby.
Yeah, no worries.
Yeah.
I wonder.
Sorry, go ahead.
I think we might be able to look at another crater, but which is like way south of the moon and
South
at the
of the
Terminator
moon.
line.
Okay. Near the Terminator line. So the Terminator, remind us all again what the Terminator is.
Oh, the Terminator line is the line that it's in between the bright and the darker side, the side that we're unable to see at the current points.
Okay, thank you. So down here somewhere, right?
A little bit more south could be.
Okay. Wow, look at all those craters.
Yes, that is beautiful.
So was it somewhere around
Oh.
here?
Okay,
Yeah.
if I could interject really quick.
Yes, go
I
ahead.
think
Go ahead,
it's
Kyle.
quite interesting thing to talk about. So, there's a crater. If oh geez, see, I haven't booted up the remote system, so I have to try and describe. So there's a crater at the very top right of the field of view, right under the little magnifying glass, that black magnifying glass by the Zoom Audio or Zoom Auto. Anyway, there's a crater up there, and it looks like there's a little white spot in the middle. And that's actually a peak at the very center. Yes, exactly. That's actually a peak at the very center of the crater. And craters of certain size will always have those little peaks. And that's because when a meteor strikes the surface, because there's so much energy, it almost liquefies the surface. So it's almost like a teardrop or a water droplet. When it hits the surface of a water, it plunges in, and then there's that little the rebound where it kind of splashes very ever so slightly. But because it's molten rock, that splashing effect will happen relatively slowly, but it will actually cool and form a central peak. And I think this only happens with craters that are about 100 kilometers across or more. So little interesting tidbit there, which is pretty cool. Some of
Yes.
those craters, you might find little peaks in the center.
Very cool. I also remember learning that some of these craters had like some spray like radiating out from the centers of the craters, where you could see like where the impact happened, and then the spray kind of just spread out. I don't really see one here. I remember there was one near the south of the moon, wasn't there?
Well, Tycho is a good example of that, actually.
Yeah. Tycho is a beautiful one.
And which one was that again? Remind me.
Tycho is the very prominent one that shows up on your camera, that there are a lot of light rays coming out.
Maybe like this one? I'm not exactly
It should
sure.
be somewhere closer to the middle.
Closer to the middle. Maybe we won't be able to see it because it's too
Yeah.
close to the Terminator, or on the
Still
other
a
side
little
of it,
bit
maybe.
early on.
Yeah. Yeah, it's probably, we can't, I don't think we can see it. All right. So, folks, we're looking at the moon. I know everyone wants to see Jupiter and Saturn. Actually, look at the sky, though. Look at this. Look at look at all the clouds. It's really miserable. It was supposed to be clear, but what can you do? The weather is the weather. Some things, in fact, many things in life we cannot control. So it helps to keep us humble, right? What can you do? But hey, the moon is fun. Should we actually see if we could try Jupiter yet, or should we explore the moon a little bit more? What do you all think?
We can certainly try. Yeah.
Actually, Abby, you've got a good view of the sky from SFU. Do you think there's any hope when you look out the window?
Actually, I'm facing the east, like instead of southwest, so that might be a little bit hard, but
Yeah. It's actually
Yeah.
in the...
Can I do my moon joke?
Oh, you have a moon joke. Yes, please, Haley.
Why did the moon put the fork down?
Oh, it's... why?
It was full. Ha 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 ha.
I love it. Why did the...
That's my contribution to the moon.
Haley, that's awesome.
yeah.
Yeah.
I've got another joke. So, how do NASA scientists throw a party on Mars?
They plan it.
They plan it. Yes, that's right.
That's a good one.
I'm sorry. All right. Now, okay, I suppose we could try it. Why not? Let's take a look. Let's see. So right now we're looking at the moon, which is in the east, southeast. And Jupiter, so are you all seeing this? Yep. Jupiter and Saturn are right here in the southwest. And there's cloud over there. But let's just, whoops, what happened? There we go. Let's see. Well, we'll go to Jupiter first because it's brighter. I mean, they should be all in the same view, but it'll be easier to center on Jupiter because it's brighter. It will be more likely to shine through the clouds when it does. So right now the telescope is moving over. You can see in the little videos here on the side. Where is it? On the left here. You can see the observatory moving. And so Jupiter and Saturn actually are visible during the day. They're bright enough. It's really quite amazing if there's no cloud. If there's cloud, then you can't see anything. But if there's no cloud, you can, if you know where to look, you can actually see these planets. So that's why we decided to start a little bit earlier today. And the other reason is because the planets will get too low to see by around 4:30 or so. So let's see what we have here. It's overexposed, of course. Whoops. Okay, what do we have here? Have we completely moved over yet? Yeah.
I actually have
It's
something
cloudy.
interesting about the moon to say.
I'm sorry?
I have something interesting to say about the moon.
Yeah.
So, have you heard of the star registry? Where you can register your name in a star?
With the planetarium, you mean?
I don't know if it's with the planetarium. I know there's
So-
a company where you can actually log in. I think Indigo sells those, where you can just buy the form and then you can pay them and then they will name a star after you and they'll send you a certificate.
Yes.
So along with that certificate, they actually send you a coupon where you could actually own 10 acres of moonland. I'm not kidding. So someone gifted me they named a star after me as a gift, and they gave me by the way, you get to, in addition to naming a star after you, you get to have 10 acres of moonland.
That's really
I said, "That
sweet
is
of
great."
that person.
That is oh yeah, totally. That made my day. I was like, that's great. I'm not even a homeowner in Vancouver, but I get to own 10 acres of land on moon. I just have to figure out how to get there.
Right.
So I have a backup plan in case it hasn't worked out on Earth. I can just go to the moon.
So Yes, those kinds of gifts are really nice. They're usually set up as fundraisers for places like the H.R. Macmillan Planetarium and other planetariums around the world. The official names of stars, since there are like millions of them, they actually usually just get a number in the sky in the official catalogs. They just get a little telephone number. But it's really nice to have these local planetariums around different parts of the world have these programs of name a star. It's a very romantic gift that people can give to people. So here we are looking at Jupiter through some cloud. I don't know if you can see, but it's right over here. There's this little slightly brighter little white thing through this cloud. And unfortunately, there's a lot of cloud here. So what can you say? What can we say? You can sort of see it. We can wait until the cloud kind of goes away and see if we can see it clearly. Saturn will be off more up and to the right. I'm not centered. I'm not pointed. Actually, what I can do is just point it so that we can actually see it more clearly. What I'm going to do is I'm going to move it right in between the planets so that we can see both Jupiter and Saturn in the same view, but we will not be able to see Saturn because Saturn will be too dim to shine through the clouds. So
yeah. So like as Joanna was mentioning about these kind of stars are like brighter stars that you can look like during sunset. So actually, meteorologists, they have different classifications of twilight. So what we're seeing now, it's called a civil twilight or maybe an earlier stage. So it actually is classified by how low the sun is below the horizon.
Yeah, so Jupiter is now right here. I don't know if you can see it. Jupiter is now right here. And Saturn should be somewhere over here, but it's right now too cloudy. So there you have it, folks. The Christmas star. I'm so sorry. I wish we could blow the clouds away for you all, but what can we do? We are mortal humans.
Well, there's still a lot of darkness to go, though. The sky's still really bright, so we should be able to see something.
Yeah, that's
maybe I could talk about binoculars for a little bit.
Oh, yes, definitely. Scott, I wanted to hear about your
if everybody listening here, if you have some binoculars at home, they are a great tool for astronomy. Not many of us realize that. So if you have some at home, go get them and point them at the moon. And I promise a lot of these things we've been talking about right now, you'll be able to see them. So like I have my binoculars here. Fortunately, my window at home, my home office, I can see the moon right now, and I'm actually looking at the Sea of Tranquility. I can see those with my binoculars up in the top right, and then way down at the south by what's the name for that line? The Terminator. Way down at the south end of the moon along the Terminator is my favorite crater. There's a big crater called Tycho. And when it gets really dark, it looks kind of like this explosion at the bottom of the moon. And it's just this huge crater, and you can almost imagine the impact that was made millions of years ago. I have no idea how old Tycho is, but you can see that something very big hit the moon near its south pole and left behind this giant crater. And it's very visible tonight. You'll be able to see it really well if you have some binoculars, and as things get a little darker, we'll also look at it later with the telescope, I'm sure. But if you want to talk more about binoculars, maybe you're thinking about buying some binoculars, and I'm going to give my tips for buying a good set of binoculars, because you go into you don't know where to buy them. You can find them online. You can find them in all kinds of stores, and who knows what to get. Now, if you have any set of binoculars, that's still really good. Like any set of binoculars, if you point them at the moon, you're going to see a lot. But if you still haven't bought a set of binoculars, here's a few tips that I have, and let's see if I can cut and paste an image into the chat.
So Scott, actually, I could probably turn your video on now. Do you want to turn your video on?
Oh, yeah, sure. If you want, I can. I
There
have
you
video
go.
now.
There you
Okay,
go.
let's see. Do I show up in
Oh,
the?
sorry, you're blue and red. I have to swap just a second.
Hey, there
There
we
we
go.
go.
Hey, welcome to the home office. Some of you might recognize me from global television doing the space news, Space Talk with Scott. So I have my binoculars right here. These are what are they? They are a Celestron Nature DX is the model, and I'll explain why I really like them. Is the first thing is they're very durable. They have this rubber coating on them that I'm not going to drop them right now, but if I drop them, they don't get hurt, and they're waterproof. I can take them anywhere. So usually the best time to do astronomy is usually when you're camping, because you're in some very dark place, and often you look up and you see so many stars and you think, oh, if only I had a telescope, or if only I had my binoculars. Well, these are great camping binoculars because they have this rubber coating. They're nice and small, they're easy to carry, and these are all things that you should think about when you buy binoculars. What will you be using them for? I use them for looking at wildlife, everywhere I go. Sometimes I go to the hockey game, back when there was hockey, and you can look right down, you can see the players talking to each other through their mask. It's pretty cool. I can read lips. I won't repeat what they say to each other, but you can see it with binoculars. Here's something else I like about these is a lot of sets of binoculars have lens caps that you remove and you put them in a case. These ones, they're just attached to the end. So they just hang off. So there's no way I'm going to lose those. So if I'm out hiking and I just drop the lens caps, there they are. They're out of the way, but it's awesome. I love it. Now, the next thing I'll show you with the binocular is there's a couple numbers for the specs, and they're going to be on the back, right? There's a focus knob right here. And I don't know if you can see this through the webcam, but it says 8 times 42. So 8, there it is right in there. And 8 is the zoom power. And then 42 is the size of my lenses here. So the 8 is a pretty good power for zoom. If you go less, you don't get much zoom. I recommend buying something either 8 or a 10. Once you go much more than that, it's really tough to hold them steady. So you might try to look at something and you can't see the detail because human hands just aren't steady enough with that much zoom. If you do get some stronger binoculars though, and you're finding you have trouble holding them steady, I usually bring this tripod with me when I go camping. It folds up nice, and you can just sit the binoculars on top. I actually have a mount for it that locks them on, and that makes things really easy to see. And then I can even take, if a friend of mine has some 20 power binoculars that are meant to only go on top of a tripod, we can use those. It's great. So yeah, anyway, these ones, if you are going to buy them, I would recommend not buying them online because you don't get to try them out first. And I've seen a lot of binoculars that are like, I'd call them either factory defects, or sometimes they're just not as advertised. And if you go into a store, you can try them out. Any of your local, usually the camping kind of outdoorsy stores would have them. I think I bought these at Bass Pro Shop. If you live in Vancouver, we have a telescope shop on Kingsway, Markarian Fine Optics, and he stocks some very nice sets of binoculars. Go see Harut there. He really knows what he's doing, and he'll get you a good pair. And yeah, you can try them out in the store and you can see all the different prices. Now, when we're talking prices, they start at about $40-50, and I've seen them go as high as $3,000 or $4,000. Now, my attitude toward binoculars, it's yes, you do get what you pay for, but I'm also a Scotch drinker, and I can't tell the difference between a $70 bottle and a $500 bottle. So I can't tell the difference between a $100 set of binoculars and a $1,000 set of binoculars. My eyes aren't that good, but I can definitely tell the difference between the $50 binoculars and the $100. And when you hold them up to your eyes, you'll just see a much clearer picture in a newer or in the more expensive set of binoculars. The cheap ones, might feel like you're looking down two little straws and you have very little circles you're looking at. And then you get some expensive ones and it really opens the view up. So you get a nice big wide field, and around the edges, the image, the more money you spend, the more clear the image is. I would suggest just going into the store, trying out a few sets and finding that picture that looks good enough for you and is going to do what you want to do. And then, like I said, get the rubber, the rubber coating, because it's very durable. Get one with the lens caps that are attached so you don't lose them. And look for either an 8 or a 10 power on the back. And yeah, you'll be good to go. And then you take them, and I can see the moon right now. So let's have a look. And I can look up, and there it is, the Sea of Tranquility. And I can see Tycho very clearly right at the south pole of the moon. It's great. Yeah, that's it. Back to you.
Thanks
Joanna.
so much, Scott. That's a really good
There's
summary.
a question in the chat to Scott. So I wonder if I should read it to you.
Oh, there's a question for Scott. Hey.
Oh yeah.
Yeah, so it's from Chuck GY. He's saying, are there binoculars with wider interocular distances?
What's an interocular distance? I don't know that much about them.
That refers to you separating the two pieces. Most are adjustable to some extent. You can pull the two pieces apart so they can adjust.
Oh, yes. So they all do. And yeah. And so they fit any face, whether you're young or big, small, whatever. So you can adjust them to whatever fits you. Now that's another reason why I say you should try them out in the store, because I've seen a friend of mine bought a nice pair online, and these are two little telescopes that we're looking at. That's all they are. And they didn't line up perfectly. So it was very hard. Yeah. And I see Chuck in the chat is saying his don't quite line up right. And sometimes they don't quite line up right. So I would highly recommend going into a store and buying them there, because you can try them out. You can always bring them back. And usually there's somebody at these aren't the kind of things they leave out on the shelf. Like these are behind a cabinet somewhere. So there's always some expert helping you who will teach you about the binoculars, and they can help you out if anything goes wrong.
And definitely through this cloud, binoculars would help you see the conjunction. Right now, we're still looking at Jupiter. I don't know if you can see, but this is Jupiter. Actually, it's getting darker, so I need to increase the exposure a little bit, and maybe you'll see it better.
I can hop on as well, because I have a pair of binoculars that are 15 by 70, if people want to see that one too, because those are stargazing so is the one that Scott showed, but this one can also see deep sky objects. People would like to see the range.
Yeah, unfortunately, we probably won't see the conjunction since there is cloud cover. But you know what? The Jupiter and Saturn will still be pretty close together for the next few days. So tomorrow it's supposed to be clear again. At least that's what the forecast says. So you'll still be able to see it. You'll still be, you don't need a pair of binoculars. If you want to actually distinguish between Jupiter and Saturn, you'll need a pair of binoculars or a telescope. But you can see it with your eyes. Jupiter and Saturn are so bright that you can see them in the daytime, right? And you can see them with your eyes. And if you have really good eyes, you might be able to tell them apart. You can separate them. But for people with eyes that are not as good, they'll look like a single bright star. So,
Joanna, would it be a good time to talk a little bit? I can just talk a little bit about the red spots.
Yes, please, Haley. Go ahead.
While you're on
Right, just before we leave binoculars, with binoculars you can also see the moons of Jupiter. Just if you prop them steady on a post or something, you'll be able to see the 4 little dots around Jupiter, even with 2 binoculars.
Yes, that's right. Jupiter actually has quite a lot of moons. I can't remember any. The number keeps getting bigger and bigger all the time. But there are 4 that are really bright. They're the most massive moons, and they're the ones that Galileo actually saw when he used his telescope, and so they're called the Galilean moons because I believe was the first to discover them. So you can see them very easily through binoculars. That's right. All right, go ahead, Haley.
Okay, great. And then also, I think Karimber is going to talk about some of the transits of the moons of Jupiter. So the red spot is a storm that is in the southern near the southern equator, I believe. It's a persistent high pressure region, and it's a anticyclonic storm. So it goes counterclockwise, and it's red, possibly because there is sulfur and the rays of the sun. Something, how all that works, I don't know exactly, but that could be causing it to be red. It is also shrinking. Since it was first observed in the 1800s, it was about 47,000 kilometers, and today Hubble measures it at about 16,000. So that's a huge difference. So it's shrinking, but they don't really know why. And there are also little red spots, and there is a black spot, and I don't know those exact locations.
Yeah, I remember. That's a good point, Haley. I remember when I was, many years ago, when I was very young, I remember memorizing a whole bunch of facts about the planets. And one of the things I memorized was that the Great Red Spot was the size of 3 Earths. Like 3 Earths could fit in the red spot. And now it's like only 1 Earth could fit in it. It really, and I suppose I'm not that old, but within my lifetime, it's shrunk quite a lot.
That's still huge that there's a storm the size of the planet Earth.
That's true. Yeah.
It's amazing.
Right. So somebody did ask what direction of the sky to look for Jupiter and Saturn. It's in the southwest. In fact, I'll show you right now where it is. Let's see, where's the Sky X? This is the planetarium software that we're using at the observatory. By the way, if you're looking for planetarium software that's free and really good, I recommend Stellarium. It's free. It's available on all platforms. And there's even a web version. So I recommend that. That's the one I use when I'm not at the observatory. Here at the observatory, we use something a bit more sophisticated, which is called the Sky X, but it's not as free. Okay, so we're looking between basically the south-southwest here and about an altitude of 16 degrees above the horizon. So I don't know if you know how to calculate angles in the sky, but one really good rule of thumb is that if you stretch out your arm and make a fist, the length of your fist is about 10 degrees. So 10 degrees up to here, and then half a fist. So basically it's a fist and a half above the horizon in the south-southwest right now. So, and it will continue going, it'll continue kind of going this way along the, it'll start to set. Just like the sun and moon sets, the planets and the stars also set. So there it is. There's Jupiter. Saturn we cannot see yet, but so even though the pair will get too low by around 4:30, you can still see it with your eyes until about 6 p.m. So they will set at around 6, maybe even just slightly before 6. So if you have a clear horizon towards the southwest, you'll still be able to see it, and they're really bright. Like they stand out against all the other stars. So you should. If it's clear enough, you shouldn't be able to miss it.
There is a question in the chat about is there any location at SFU where it's really dark for stargazing?
For stargazing, actually the plaza around the observatory right now, there are lots of lights for Christmas that they've put up, which is nice and cheery for non-astronomers, but it's a little bit, it can block a little bit of the night seeing, but usually like when it's not the holidays and that they haven't all put the lights up around the plaza is actually a pretty good place. It's pretty clear. You've got a pretty good view of the south, which has all the best stuff, and there's also there's a little hill inside the quadrangle actually, which is also a nice place there. I mean, aside from that, if you don't want to go all the way up the mountain, here, like in Vancouver, in the middle of Vancouver, actually QE Park is a pretty good place. There are a couple of places with good views, clear horizons. I'm not sure.
Yeah, I would recommend. It depends what direction you're trying to look. I like to go. Spanish Banks is a great place. What you're looking for is anywhere where there's no street lights, because lights will just ruin your night of astronomy. So Spanish Banks is a great spot in Vancouver for looking up and to the north. The downside is you have UBC and the mountain to the south, so you wouldn't be able to see the conjunction from there tonight. Also, any one of those little parks along, Point Grey Road that goes out that way. There's about 10 little parks right along the ocean there that are great for looking north. That's where I saw the comet in the spring. Queen Elizabeth Park, if you go to the north side of there, below the Bloedel Conservatory, there's a parking lot there that there's no lighting around it. So even though you're in the middle of Vancouver, there's like trees that block all the lights, and it's actually a good spot for looking up or looking south. And that would be my number one choice from Vancouver. If I was looking for the conjunction. But a great thing about the conjunction is because we're talking planets and the moon are very bright. Like, I live in Yaletown and I look at the moon from here all the time. And the planets and the moon are, light pollution doesn't matter because you can always see them. It's when you start looking for galaxies and star clusters and all the other fun things that light pollution really comes into play. One more thing on the plaza, the astronomy plaza at SFU, is it was designed specifically for personal telescopes. And I think a number of us in this chat here were part of the design committee that helped put it together. So the benches that are up there, they're this star shape, but they're also very good. If you set up your telescope on one of those benches, you can, sometimes when you need to look up, you can stand on the bench, or if you are looking low toward the horizon, you can like stand on the ground. And then people of all different heights and everything that you're looking at, it's usually an issue when you're doing astronomy, and it's not just by the design of those benches. So I highly recommend using that plaza whenever possible. It's we can see it in the two outside pictures right now on the screen. And a lot of those benches are just ideal for astronomy, for setting up your telescope. I've had just some great nights up there. It's really, until you've actually used them and then tried to set up in like a flat field, it's like you don't realize how great they are and how much more convenient your night of astronomy would be. It's when I think of astronomy, like, yes, there's this big fancy observatory up there, but if I always find, like, look at all that equipment there, and props to you, Joanna, for setting this up and all those dials, but I see that and that's confusing to me, and I am not smart enough to run that observatory. And here I'm the guy on Global News doing space talk, like I'm the space guy, and that's overwhelming for me. So I always try to keep things as simple as possible, so I can just, like, I get there, it takes me 2 minutes to set up my gear. I have my binoculars, I have a really simple telescope, and I can just point it at stuff and look at it. Like, I'm not trying to do photography. I'm not trying to do, auto tracking or any of these other fancy things that are just going to add more confusion to my night. I have a telescope, I put it on the ground or on a bench, and I just look at stuff. And if you go about it that way, you're really going to have a good time, especially if you're brand new to astronomy.
So Scott, there have been several times during this pandemic when I've been remote observing because we're not supposed to be on campus. But there's been several times, and I always monitor the webcams just in case anything goes wrong. And I usually see someone right here by this little star bench. Is that you?
I honestly haven't been up there in 2020. I've been trying to, because of everything going on this year, I've been trying to go more to remote locations and parks. But if you've been doing that in 2019, I'm probably up there every second week. If the clouds are gone, I'm heading there.
Right. Okay. Yeah. I mean, because I often see, and I often see one particular person that uses this particular bench every time, and I've always wanted to know who that person was, and I've always wanted to go and say hi, but it's always a bit of a ways for me to get there.
Yeah, there are a few of us who are up there. Like, there's some regulars, so I bump into the same people 3 or 4 times a year, and there's a handful of us that go there all the time, and then of course every time there's a Starry Nights event, the place is just packed, and it's a great time.
Yes, we normally have we definitely hugely appreciate the Royal Astronomical Society coming and helping and setting up their personal telescopes in this plaza. It's a great event when it's in person. Unfortunately, we can't do it in person these days, but it's such a nice thing to have people being able to. And whenever I've been there, I've always gone and looked through somebody's telescope, personal telescope. It's always a lot of fun just to because the big telescope is nice as well, but you have to stand in line, and it's you don't get to look at something right away, and they stay on the same object for like forever until they move to a different one. And so it's nice to be able to have the RASC members there with their telescopes, and we can see different objects throughout the night. So we really appreciate that.
Well, thank you. And yeah, another thing I would point out is the big telescope. It's very fancy, and it's breathtaking, and it's amazing when you look at it. But if you're just looking at stuff, a personal telescope with a really nice eyepiece in it it gives you even a better image than that big telescope does. So when I look at that big telescope there, it's designed for all kinds of other things. It's not really designed for putting your eye up to the eyepiece. Like, it's very good at photography. And I know that, I know there was a student studying Cepheid variables. So you're gathering all this data on like star intensity and the color of the star, and they're capturing data over the course of a night. And it was designed for all these things that aren't like looking at stuff. And that's what I want to do. I want to look at stuff. I don't want to do science. And so just a little personal telescope that you set up on the bench, if you're just looking through the eyepiece, you'll actually have a better experience and see better than you will through that big scope.
Yeah, for sure. Hey, look, it might be clearing a little bit. Maybe?
Yeah, it's actually clearing on the east, as I can see here from the mountain.
Am I speaking slightly too soon? I don't know. We'll see. Okay, well, I'll keep increasing the exposure as it gets darker, and we'll see if we can see a little bit more. Actually, maybe even... Okay, there we go. Yeah, for sure. So, Scott, I hear what you're saying. A lot of professional astronomers... I am a professional astronomer, and a lot of my colleagues... I don't even know what a telescope is. It's kind of embarrassing a little bit, but I mean, a lot of my colleagues are theorists, so they'll use a pen and paper or a computer to calculate things about the universe. But it really nothing beats looking at something, sitting there. Like, for example, one of my favorite objects in the universe is the Andromeda galaxy, and we've seen that a couple of times in our virtual Starry Nights events here, and we've seen them a couple of times in person as well. The Andromeda galaxy is actually visible to the naked eye. It's hard to see it in the city, but it's visible to the naked eye, and it's just really awe-inspiring to realize that the Andromeda galaxy is something like 2 million light years away. And so the photons traveled all that distance for all that time before they're finally hitting my eyeball. Hitting the camera pixels, that's one thing, but actually hitting my eyeball, now that's kind of cool to see. Like, it's a kind of a connection that you don't get if you're just staring at the computer. But of course, I also love computers, and I also love how computers can tell us a lot about the universe that we wouldn't have been able to discover otherwise. So there are pros and cons, I guess. So there is Jupiter. Now it's still a little bit too cloud covered for Saturn. Well, let's increase the exposure even more. Oh, nope, too much. There we go. That's better. Hey, there it is. You can see it. It's right there. Look at that. There's Saturn. You can barely see it. I don't know if you can see it. I can see it on my screen. But there it is. Maybe we might get a little bit more luck later.
I can see a fuzzy thing to the left. What's that?
This one? That's Jupiter.
Oh, the other left.
This is Saturn.
Okay, yeah.
Yeah, that's Saturn right there. So let's see if we can... Increasing the exposure might help. But anyway, there you go. So it's also lower down on the horizon now. It's pretty low. What are we at right now? We are at 15 degrees. That's pretty low. So we're getting to near the edge of when it'll start to disappear below our horizon. Oh, I'm starting to see a little bit of the disk too, the rings a little bit. It's a little bit elongated. I don't know if you can see it. I'm so used to looking at little fuzzes.
I don't think we can on the YouTube stream yet. It seems to be downrising it just enough we can't see it, but we can. Jupiter's really coming in well now.
Yeah. Yeah, oh, you can't see it on the YouTube thing. Hey, I definitely increased the resolution for the stream this time, but I guess it didn't. It's hard. I'm also used to looking at little fuzzes, right? Because I guess a lot of amateur astronomers are. We're used to looking at fuzzes and seeing things in them. And so it can be harder for somebody who isn't used to that. And everyone else is used to Hubble pictures, right? But yes. Well, hopefully, hey, as it gets darker, hopefully we'll be able to see more of Saturn there.
We'll definitely see it. It's only 4:15, so the sun is just set. So we've still got it'll be getting darker for another half an hour at least, and it'll come out in the next 5 to 10 minutes, I bet.
Yeah, let's hope.
Yeah, if I can jump in to add something about Saturn rings, if that's okay.
Sure, no problem, Abby. Please go ahead.
Yeah, so if you're looking at, clearly if you're looking through this telescope, you'll be able to see a tiny ring around Saturn, which is super amazing. But if you're looking into some of the Hubble's image, you might see there's a very dark region on Saturn's ring. So that region is called the Cassini gap, or the Cassini division. So the Cassini division, it's actually a rather empty and a place where there are not a lot of material. So actually, a lot of people, they question what's wrong with Saturn, why there's a ring with it, and what's the ring made of. So actually, the ring of Saturn is not a flat cardboard. Instead, it's a lot of icy, rocky debris that's surrounding Saturn. And Saturn happens to have a moon called Mimas that's very close to Saturn that pulls a lot of gravity on the debris. So that's why there's a very dark region formed in between the two rings of Saturn.
That's really cool. The rings, and in fact, in this telescope, you normally would be able to see that little gap. I mean, it's a little bit hard to see, especially with the atmospheric blurring, but if you blink a couple of times, you can actually see the little gap between the rings, which is kind of fun to see. And Saturn is also one of my other favorite objects in the universe because it looks really three-dimensional. You know, it's like because things in the sky, because our eyes, we normally see 3D because we have two eyes, right? If we have two eyes, we can see in 3 dimensions, but only for short distances, like on the scale of a couple of blocks or something. But once it's farther and farther away, things look more and more two-dimensional. And so in space, things are really far away, so things look two-dimensional. But with Saturn, you can really see it's really three-dimensional, which is kind of fun. Okay, I'm not doing very well here. Okay, why don't we increase the exposure? Right. Yes. So does anybody want to volunteer maybe a little story of how they got interested in astronomy?
I can start.
Thank you, Kyle.
That's okay. Yeah. And it's kind of funny. These interests and oftentimes career-defining moments can start out pretty small. And it actually, it happened to me when I was on a trip to visit my grandparents in Nova Scotia. And my mom was kind of saying, "Oh, your cousin's grandfather has built his own observatory in the backyard, like a little small observatory. Do you want to go and see?" I was like, "Yeah, sure, that sounds great." And I was like, 6 or 7 or something like that. And so we go over. It was just like 20 minutes from grandparents' place. And this was in August, and this was around the time, I think it's the Perseid meteor shower was going on at that time. I didn't know that. We were just going over to have a look. And in Nova Scotia, the only major source of light is Halifax, which was about an hour away from where we were. So that was pretty nice. But going out into the country, and that was my first time seeing the Milky Way, and the sky was just lit with thousands of stars. It was like a cityscape in the sky. And it was that much better when every minute or two there would be a meteor that would streak across the sky. And seeing that whole scene, that whole grandeur, was just going, all right, this is what I want to do, is this stuff. So and since then I've been studying it all the time, all over the place, and it's been fantastic. But that was my little humble beginnings.
Yeah, I remember watching the Perseid meteor shower as well when I was a kid. It was, somebody was we were talking about great places to do some stargazing. I grew up in Richmond, and a great place to go in Richmond is Gary Point, actually. At least it used to be. I haven't been there in a long time. I don't know if there are lights there now, but it used to be quite dark there, and it was really nice. I think it does close after a certain time, so you do have to look at what the hours are, but I remember as a kid, I would gather some friends, and we would watch the Perseid meteor shower from that beach. Hey, there we go. Hey, we can see a little, I don't know if you can see it. I can see it. You can see a little bit of Saturn here. You can see it's not Jupiter is very clearly a circle, but Saturn is a little bit more of a sausage. Can you see that? Hello? Did I lose people?
Yeah, I can see it. It looks like a smudge right now, but it'll definitely clear up as the sky gets a bit darker. I think in 5 minutes it's gonna look quite a bit better.
Yeah. Yay! We're starting to see something.
I can see it. It looks great, Joanna.
Looking good on my end too.
This definitely doesn't look as... I don't know how many people saw some... There were live streams that were broadcast from other observatories that had better weather yesterday. And I saw some of their pictures. Wow, they were amazing. Unfortunately, we can't compare because of our weather, but what can you do?
Joanna, it's Haley. I joined quite a few live streams yesterday and was able to... I felt like it was... it's called the Great Conjunction, but the great part of it was, for me, my first global astronomy event, where I was able to watch something with other people around the world. And really amazing to see in Zimbabwe, they were building a observatory made out of bamboo. And seeing people and how they were observing was amazing around the world.
That is so cool. One of the things that I love about astronomy is that it's so universal in the sense of, everyone can see the sky, everyone can see the stars, everyone can, it's something that has caused wonder and amazement and inspiration for our entire history. So, yeah, that's one of the things I love about astronomy. So this conjunction is... So it is called the Great Conjunction. And so why is it called the Great Conjunction? So I actually looked this up because I was like, well, what makes a great conjunction? Is it less than, 0.2 arc minutes or whatever, arc seconds, in separation? And it has something to do with how wide they're separated. But actually, no, it's not. Great conjunctions are reserved for conjunctions between Jupiter and Saturn. So Jupiter and Saturn only. And so they're Jupiter and Venus do also have conjunctions, and Venus is a lot brighter, so it's usually a bit more spectacular. But Jupiter and Venus have conjunctions far more frequently. However, Jupiter and Saturn do not have conjunctions very frequently, so they're called great conjunctions. And Jupiter and Saturn, however, like to get this close, this only happens like maybe in pairs every 400 years. So the next time this will happen, like that they will meet this close, is in 60 years. But then after that, it'll be another 400 years before they get together really close again. Now, why? Why is that the case? Does anybody wonder why?
Oh, sorry.
I did look this up. Actually, it's pretty logical as well. If you think about it, oh, sorry, I just okay. Sorry, I just lost my screen. Where did it go? There it is. Okay. Well, so why is it? So the reason is because, well, first of all, Jupiter and Saturn take forever to go around the sun. Like Earth only takes 1 year, but Jupiter and Saturn are much farther away, so they take a lot longer. So it takes a lot longer for them to line up. But even when they line up about every 20 years, compared like relative to Earth. But even though every 20 years they line up, they're nowhere near as close as this. And the reason is because if you imagine the orbits of the planets as circles and you put them on a table, flat on a table, well, it turns out their circles are actually not quite flat. They're slightly tilted by like 1 or 2 degrees, and that's enough so that every time they're sort of in the right line compared to Earth, like if you're standing on Earth, they look like they're the closest together, but they're still not that close because of the slight tilt of their orbit compared to the orbit of the Earth, actually. So that's why conjunctions between Jupiter and Saturn are so rare. Yeah.
Actually, if I can jump in
Yes,
to add
please.
to that. Yeah. So I was watching one of the live streams yesterday from somewhere else, and one of the panelists there was talking about in the future what the conjunctions will look like. And she said there will be a time where Jupiter will actually pass in front of Saturn. And it was really interesting, but this will not happen for like the next 5,000 years. But if you kind of extrapolate from this kind of stuff, there will be a time when Jupiter will actually pass in front of Saturn, and that will be certainly spectacular to see.
Oh, definitely. That definitely would be so cool.
I can make another prediction on that night. It's going to be cloudy.
Especially in Vancouver, right? Unless, hey, you know what? Climate change may work in our favor in that sense. No, I'm kidding. That's terrible. That's a terrible joke. We shouldn't hope for climate change, even for astronomy. All right. Look at that.
Well, observing is actually better when it's cold. I'm just saying. We get the air tends to be a lot more clear. So yeah, I would say anybody looking to do some observing this winter, if you wait for when some of these high pressure systems come through, even though it's really cold outside, like astronomy is not a warm hobby, and the best nights are these winter nights where you get really cold, crisp air, but you have very stable atmospheres, and the observing the stars up above are just so much more clear in the winter than they are in the summer. So it's just something to look forward to. If you see a clear streak in the calendar, that's a great time to plan to get outside in the evenings and do some observing.
Yeah, definitely. I was actually at the observatory a couple of nights ago, where it was before the whole huge bout of rain. Before that, it was so cold, it was freezing. And actually, I'm going to be teaching a course this spring at SFU on it's basically techniques for observational astronomy and measuring things, like how do we know that this particular star cluster is a particular age or whatever. How do we know these things? So we're going to it's going to be really fun. We're going to take pictures and we're going to derive physical things from the picture. So we're going to go from the picture to the numbers, so that'll be really fun. But one thing that is really unfortunate is that we can't do this in person, and so the students won't be able to have the experience of freezing their butts off in the observatory, trying to stamp their feet and keep warm. But it's not just like, it is cold, but it's also, there's something magical about standing out there in the cold, under a dark sky and looking at the stars. I don't know how to describe it. Other people might find that torture, but it's actually kind of fun. So it's too bad we're not going to be able to do that in person, but we'll be doing it online, and so we'll all be comfortable and warm in our own homes and taking data with a mug of tea in comfort.
Yeah, I do agree with you that I prefer to do stargazing in the winter, not only because like it's clearer, because the bugs will stay away from me because there are no bugs in the winter. That's like one of the best thing about it for me.
That's a really good point, Abby. Oh, those bugs are annoying.
Yeah, they're annoying.
Well, they say the two most important pieces of equipment for astronomy is in the winter you need a very good coat, and in the summer you need bug spray.
I think the advantage is I can actually start observing at like 5 or 6. I don't have to wait till 11 or midnight. And so you have so much more time and earlier. I like that.
Yeah.
I think it's a bit of a West Coast. Both Haley and I grew up in Winnipeg, and Winnipeg in the winter is a lot different than Vancouver in the winter.
That makes sense.
At 9 or 30, you don't last long, even if you love the stars.
I did, yeah, and I never understood why I didn't really learn it growing up. It was just it's too cold. That's why they don't really, maybe we didn't do it then.
Yeah.
Saturn looks really good on the YouTube feed right now, Dr. Wu.
Yeah, it's starting to look a lot better. That's true. Let's see. So there it is. There's Saturn. There's Jupiter. It's not great quality because of the cloud in the way. It's also really low on the horizon. So if they're really low in the sky, it means that we're looking through a lot more atmosphere. So the light has to travel through a lot of atmosphere, and that atmosphere is turbulent and causes blurring of images. So unfortunately, it's a little bit blurry, but hey, you can see it. I can actually start to see the gap between the rings now. I mean, meaning like I can see the ball of Saturn and the rings around it. I don't know if you can. I guess because I'm doing the stream, I get the benefit of seeing the actual screen.
Yeah, I can see it too.
Oh, yeah? Oh, good.
Yeah.
Yeah, we did it. Yay!
Yay! We saw it. We saw the Christmas star. Oh, yeah. So some people have asked me, why is it called the Christmas star? So apparently, so the story of the Star of Bethlehem, from the story of Christmas, right, has the Star of Bethlehem. One of the leading explanations behind that story is actually a planetary conjunction, just like this. So it's kind of cool that we're seeing this right around Christmas time. It's a nice little coincidence.
Yeah, I believe it's cool. And I actually heard there are astronomers who run simulation that around 2,000 years ago, it's actually a conjunction and overlap of 3 stars, so which is Venus, Saturn, and Jupiter. So just like you said, like the more often one and the more rare one happening together.
Right, yeah. So there are different, so you can do this yourself, right? So Stellarium is the planetarium software I was telling you about. You can just put in whatever date you want. If you want to see what astronomy happened at a particular, historical event, you can go and check it yourself. So I think one of the confusions around what was the Star of Bethlehem was like what year to put the event on. So there's a little bit of confusion with that, but there are several different conjunction theories, but the conjunction theories are definitely more plausible than a comet or a supernova or things like that. There were several reasons for it, and I can't remember all of the reasons, but one of them is that the comet was usually a bad sign, which is kind of weird, right? We all saw the comet this summer, and it was so beautiful. It was something, for me, it was like, why did it used to be a sign of bad things to come? It's always like, it's so beautiful. I would have thought it would have, if it had been an omen for anything, it would have been an omen for something good, right? But apparently, I think one of the Caesars, it was either Julius Caesar or Augustus, there was a comet that happened at the start of their reign, and they used it as a sign, they told the public that, hey, because this comet is a sign that I'm supposed to be the Caesar or something. If anybody here is an expert at ancient history, please do speak up, because I am definitely not. So I admit my ignorance here in this case.
One thing, the RASC just had a very interesting seminar last night in the History Committee. And apparently a leading theory is now an astrological theory, not an astronomy theory. So it's rooted that it wasn't that the star Bethlehem was not an event in the sky. It was actually an event in a horoscope. So something they looked down at usually a piece of paper at, rather than up in the sky. And it basically predicted the birth of a great king in Judea, this horoscope. And so apparently some people are really taken by this theory that astronomers have been biased towards an astronomical theory, because that's what we believe nowadays. Whereas the three magi were actually astrologers, and they believed their beliefs are quite different than ours now. But if you go to RASC.ca, I think you'll be able to find the recorded video of that. It's quite a different.
That's interesting. I've never heard that theory before. That's interesting. Yeah, there are lots of them. I know that I've heard that there are lots of theories, and a lot of them are conjunction theories. But I've never heard of an astrological theory before. That's interesting. So, what is the sky looking like from? I don't know where all of you are, but I'm actually looking out my window right now, and the southwest. I have a south-facing view. I'm looking in the southwest, and I don't see anything. I saw cloud. I do see a little bit of cloud, unfortunately. I don't know if any of you see anything. What are we at right now? Oh, looks like Saturn has gone below. Oh, wait, actually, let me increase the exposure and see if we can see anything more. It looks like Saturn may have gone behind that building there. Do you see that building? Right. It might be that this is blocking some of the view, but let's increase the exposure even more. Whoops, no, that's too much. Hey, there it is! Hey!
The video lags about 10 seconds behind the audio, so...
Oh, yeah, sorry.
There it is. Oh my gosh!
Look, it's Jupiter and Saturn. You can see Saturn a lot more clearly now. Look at that. Well, sorry, in 10 seconds.
Yay, Saturn.
Can you see it?
Yeah, I can see it, and I think the sky is clearing up here now.
Yeah. Okay, I'm going to stand up and I'm going to take a look to see if I can see it from my window. Everyone should do that, by the way. Please try and look, in the southwest. We're really pushing our limit for the telescope right now to be able to follow it. But it'll still be in the sky for humans to see, at least for a while yet. We're at 15 degrees, so it should be up there. I'm just trying to see. So I'm using, so for those of you, I really do use my fist to try to judge where to look. There's also, by the way, there are planetarium apps that you can download for your phone, including Stellarium, and that might help you as well. But it's I find it's a little bit easier and more accurate with my fist.
No, I can actually see the gap through YouTube, so it looks good.
Yeah. Whoops. Where'd it go? There. We are at 13 degrees altitude and an azimuth of 214. So that means if you have 0 at north and then you go around to the west, that's 90, and then 180 is to the south, and then 214, it means southwest. So that's what it is. So I'm going to try to see if I can see it here. Yeah, I don't know if anybody else sees it. Okay, I'm going to use my binoculars because Scott was saying that binoculars are really helpful. Actually, I pulled out my binoculars before this event just to make sure I do have them handy to see. Well, it is really nice to be able to see it finally in the telescope. Let's see if we can increase the exposure even more. How's that? Yeah, so as you can see, we've had to overexpose Jupiter a little bit. Well, maybe what will it? Jupiter. I mean, the sky is really blurring the Jupiter. But if I go down again in the exposure time, let's see if we can see Jupiter any more clearly. No. Not really. No, we can't see Jupiter any more clearly, but we can see the pair together like this.
If everyone has their binoculars handy, the moon looks incredible right now. It's a little bit darker, and now the Terminator is it's much more clear. And if you look down at the south pole of the moon, the Terminator is right on Tycho. So that very big crater there is that's Tycho, and you can see how deep it is. It's I think Abby was saying earlier about how the Terminator is the line. It's basically the sunset on the moon, and I don't like looking at the full moon because you don't get any of that contrast. When you get the sunset, you start seeing all the mountains on the moon and the shadows, and right now you can really get a good idea of how deep that Tycho crater really is and how big the mountains are, all along the middle of the moon.
All right, folks, I found it. So right now I'm just looking out my window and I'm actually seeing, we'll see the moon. Thank you, Scott. We will see the moon again after after we really can't track Jupiter and Saturn anymore. But just so you know, the sky is dark enough now so that you can barely see Jupiter. Jupiter it's about where the sky X told us it would be. But I can see it right now. I don't know if any of you have a southern view, but it's oh cool. Oh yeah, I mean looking at it with my binoculars right now, and I can see Saturn beside it as well. So I'm in Vancouver, which is a little bit clearer right now than Burnaby. It looks like. So if any of you have a southern view, then please do take a peek. But the view, of course, from the camera is a lot better. Wow, we can see Saturn! Look at that! Yeah, now you can really, I hope you can all see this as well. You can really see the rings here beside it. This is very rare to be able to, as I said, it is rare to be able to have this to both planets in one shot like that. I think even tomorrow they'll be too far for this particular field of view. I mean, we could probably expand our field of view a little bit. Maybe tomorrow we could possibly see this as well. It doesn't last very long. As you can see, in the next few days they'll just get farther and farther apart. I can see right now with my eyes, I can see Jupiter, and I don't see Saturn beside it with my eyes. With my binoculars, I can. But it does kind of look like a single star. But maybe it's only because the atmosphere, the sky is still a little bit too bright. I mean, it'll be up for a bit. I mean, we'll have it. They won't set until around 6 p.m., as I said before.
Joanna, it's pretty cool to have. I mean, is there a possibility that we will ever see an image like this again? Is it sort of like a once in a lifetime to see these two planets like this?
Yeah, it basically is. So in 60 years, we'll be able to see this again. And then after that, it'll be 400 years.
Don't know if I'm going to be around, so I'm just assuming that this image, which it's really beautiful. So thank you so much for doing this. It's a really beautiful, beautiful image. I hope we can capture that and share it somewhere. It's amazing.
Yeah, you're right.
Screenshot.
I've got to take a screenshot. I probably have a better view than you do because of the YouTube streaming. I'm not sure, but I am going to take a little bit of a screen capture so that it's not, not as pretty as it could have been, but it's still very, very pretty.
Can we see any of the moons?
I do not see any at the moment, but maybe as I increase the exposure. Oh yeah! I can see two of them right here. One here and one here. Oh, I think there might be... No, I only see two for sure. I don't know if you see it. Do you? It'll take 10 seconds. So for those of you who know something about astronomy and imaging, I didn't have time to take a new flat. I had a flat that was really good from a couple of weeks ago, but then I changed out the camera and put in our spectroscope because I was doing some spectroscopic measurements, and then we put the camera back in. But once you change out the cameras, you have to take new flats, and it wasn't. The weather wasn't good enough to take new flats, so I'm using the old flat right now, and it's not very good, as you can see. So you can see a few little things here and there, but so the image isn't totally, like, the background should be completely uniform, which it's not. But you should be able to see. Wow, it's getting darker and darker really quickly. So I don't know. Do you see the moons? Anyone see the moons? These two things?
I couldn't see it on my end right now, but I think if I wait for it, I think I will see it.
Yeah. I want to see if I could try to focus it just a tad. I don't know. I mean, that was another thing I had to do, was refocus the camera. I may not have done a great job of it. Let's see if this does anything.
But for me, back in the summer when I was doing some observing for Saturn and Jupiter, I was actually able to see the moon of Jupiter with my own telescope. It's actually really amazing view when you first saw it.
Yeah, they're pretty. They're very bright. In fact, they're visible in binoculars even. So if you have a pair of binoculars, you can see the moons. Okay, I think that made the focus worse. I think I actually had it pretty good before. Let's see again. Went back. And I think also it's getting darker really fast, so I have to keep changing the exposure pretty quickly. So does anybody else see the moons? It's just me.
I can still see the moon.
The moons of Jupiter, I mean.
Not able to see the moons.
You're not able to see the moons of Jupiter, okay.
Oh, I can see the moon now, the two of them. I can see two of them.
One here and one here.
Yeah. I only see Saturn and Jupiter now on the YouTube.
Okay.
Yeah, we can see the moons down and to the right. There's two of them there.
Oh, good, yeah. So there's one there and one there, yeah.
Do we know which moons those are?
Oh, yeah. So we'll have to look at... So there are... Stellarium actually has them all labeled, but also there are different websites that you can look. Let me see. I did make a note to myself to write it down, but I didn't write it down so that I could tell you which ones they were. They actually orbit Jupiter really quickly. So within like a few hours, you can already see them move quite a lot. And so one of the experiments that we like to ask undergrads to do, at least in when I was teaching a similar course in Switzerland. We had them actually calculate the mass of Jupiter based on the motion of based on the motion of the moons of Jupiter. Sorry. Apologies for that. Okay, so I have found that the two are Io and Ganymede. Actually, I have heard that, I have it on good authority, that it's actually not pronounced Ganymede. If you speak Greek, it's pronounced Ganymedes or something. That one right here, Ganymedes, and that would be Io or something. But I don't speak Greek, so some of you maybe online who do can correct me.
Well, according to the Greeks, the planet with the funny name is Oranos. So I just wanted to...
Uranos, that's right. Uranos.
Oranos with an O.
Yeah. That's right.
An interesting thing about, I'll say Ganymede, it's actually the largest satellite in the solar system, and it's actually bigger than some of the planets. So it's bigger than Mercury, and also bigger than Pluto, the dwarf planet Pluto.
It's bigger than Pluto, yeah. Is it bigger than anything? Is it bigger than Mercury?
Yeah, it's also bigger than Mercury.
It's also bigger than Mercury. Wow. Whoops, sorry, overexposed.
Then the second biggest moon, Castillo, is slightly smaller than Mercury, but it's only by a few kilometers diameter. So they're basically like less than 10 kilometers diameter. So the second biggest moon is identical to or same size as Mercury.
Right.
And that's Castillo.
Yeah, so as I remember, 4 of the moons, like the brightest moon of Jupiter, are also called the Galilean moons because Galileo discovered them.
Yeah, that's right. He could see it. He could see them in his little telescope as well.
Yeah, like I was like kind of trying to echo into the earlier discussion about binoculars. I was gonna share that my binoculars was actually meant for hiking and bird viewing, but I can still use it like for observing the night sky. So try to have a different perspective. Like instead of pointing towards a bird, you can point to the night sky. So just like Galileo, he wasn't the person who invented a telescope. Instead, like he was the first person to point the telescope at the night sky and made a lot of great discoveries, such as like the 4 moons of Jupiter, like the phases of Venus, and a lot of great stuff, and also like the craters and the mountains like on moons. So I think that's kind of something that's really amazing.
Yeah, that's true. That's you can see a lot with binoculars. It's true. It's pretty amazing. So the sky is pretty dark now. You can, if you have a south-facing window, it's a lot easier to see Jupiter right now, and I cannot see Saturn beside it. So maybe, I don't know, my eyes aren't great. It looks like a single star to me. Maybe there's a little fuzz beside it. I'm not sure.
If you turn down the exposure a bit, can we see the lines on Jupiter right now?
Sure, let's try that. Okay. That's still too high.
Saturn looks incredible through the telescope, by the way.
Yeah, looks pretty amazing. Okay, so there is Jupiter. It's a little bit, yeah, it's really fuzzy because of the atmosphere right now. I think I've focused it the best I can at the moment. So but normally when Jupiter is higher up, you can see the bands of Jupiter quite well. And I'm not saying bands as in musical bands, although that would be a really cool name for a musical group, right? The band of Jupiter or something. But anyways, I'm talking about the cloud bands. The band, maybe kind of a concert, a multi-group concert called the Bands of Jupiter. That's really dorky. I apologize.
Every now and then we get a frame where we can see the bands on Jupiter.
Yeah.
You can see them. They're going to be along the same line as the as the moons of Jupiter. So
Yeah.
diagonally from the top left to the bottom right,
Yeah.
and that's basically the equator, and all the moons of Jupiter, or most of them, orbit along that equator.
Yeah. Yeah, you can kind of see one of them, at least one of the darker ones. At least I can. I don't know if you can see. Yeah, sometimes you do get a frame.
But interesting that we totally lose Saturn when you turn it down like that.
Yeah, because the dynamic range is very, very different. Well, let's see if I can try to adjust the dynamic range so we can see both the bands and Saturn.
So any of you who have ever seen a picture where they show Jupiter and its moons, and Jupiter has all the bands and you also see all the moons, a little secret of astronomers is that's not one picture. There's actually, they do a short exposure to get the planet and then a longer exposure to get the moons. And oftentimes, well, one of our panelists here, Ken Jackson, is an incredible astrophotographer, and he layers often thousands of individual images to get the final product. So something that I tell people when they're looking at getting their first telescope is just forget about doing astrophotography with it, because in order to get a really nice image of a galaxy or a nebula or something, it takes a lot of skill and a lot of equipment and experience. So when you go buy that first telescope, just look through it and enjoy what you see. And occasionally, if you want a picture, hold your phone up to the eyepiece and have a look.
Yeah.
That way.
You can actually get nice pictures through if you hold your cell phone up. Like, for example, the moon. You get gorgeous pictures of the moon if you use your cell phone up to the eyepiece.
Yeah, but forget about getting the magazine quality photos of like the Crab Nebula and all these very deep, fuzzy objects.
Yeah, for sure.
I'll disagree with Rob a bit. I think imaging of the planets is actually pretty easy. Imaging faint galaxies and stuff is hard, especially from the city. But it's not too difficult to pick up how to image the planets.
That's true, yeah.
I think a lot of planet imaging too, correct me if I'm wrong, Ken, but I think it's kind of like taking Christmas pictures with your children when you sit them on Santa's lap, and you take about 1,000 pictures and you hope that one or two of them come out clear.
Yeah. And you call it lucky imaging. It's a good name for it.
Yeah, it's when you get, it's because the atmosphere is so turbulent. It's always moving, and so it causes a shift in the image all the time. But sometimes some people take videos. Actually, what we're doing is basically, I haven't been recording, but I haven't been recording the image. But what you can do is you can take an image, and one of your frames might be at exactly the right time when the atmosphere is still for just a split second, and that's called lucky imaging. And we actually have a really good picture of Jupiter using that technique. Howard and Oleg, another RASC member, made a beautiful picture of Jupiter that way. Let's see, so we are looking at Jupiter, Io, Ganymede, and Saturn. Actually, so there's supposed to be the brightest moon of Saturn, which is Titan, is supposed to be up here somewhere. But right now we can't see it. Let me expose it a little more. Actually, if I expose, oh no, I don't want to expose that high. The longer I expose it, the more blurry it'll be. Actually, maybe I should do shorter exposures. Shorter exposures, it'll be less blurry. Although longer exposures will let you see the moons more. Look at that! I thought that this would get too low by 4:30, and it's now 5 o'clock, and it's still high enough for us to see.
Joanna, it looks great. I definitely see two moons.
Yeah, I mean, I can move it around a bit. The other two moons of Jupiter are supposed to be up here, So I can move it so we could see that, but Saturn might get out of the way. Let's see. Okay, don't move too much. There, you can see 2 more right here. You see that? Oh, it'll take 10 seconds. Sorry. There we go. Oops, what happened? There. I think you should be able to see the moons now. Hey! Oh, it's just getting darker and darker, that's why.
Yeah, I see. I see the third one. That's great. Oh.
All 4 of them look spectacular. Just saw them for a second.
Okay, we're exposing this a little more now. There. Stay. Oh no. It's getting darker quick. Wow. Okay, so this should stay with us for a bit. But look how fast the sky is getting dark. Like every second I have to adjust it. Or is that something else that's in the way? Is that why is it changing brightness? I'm not entirely sure why it's changing brightness and I'm not doing anything. But anyways, you can see all 4 of them. So those are the 4. Okay, which ones are they? Okay, so this is Europa and this one's Callisto, according to Stellarium. Europa, Callisto, Io, and Ganymede. Yeah, we're getting really, so because I increased the exposure, because we have to look through now 2 seconds of atmosphere, it makes the images a lot fuzzier. I just did that so you could see the moons, but we could go back to a shorter exposure so we can see Jupiter and Saturn a bit more crisply. That's a little better. Maybe. Maybe not. Let me see.
We might be able to see Io moving tonight. No, you don't see it real time, but what I did was I just took a screenshot, and then if I take another screenshot in about half an hour, that one that's closest to Jupiter, just down and to the right, that one might have moved a little bit. So
yeah, they move pretty quickly.
Compare screenshots over half an hour to see if they move.
So again, I'm just doing shorter exposures so that we can have a better, like, crisper images of the planets.
Yeah, the close moon there, Io, it has an orbital period of less than 2 days. So it's you come back a few hours later, and it'll definitely be in a different position.
Yeah. We to do this measurement of the mass of Jupiter, you have to use Newton's laws, right? So you do measure the how fast these moons are moving. You take pictures. So the experiment that we did in that one project was just one night. You just take pictures of the planet over the course of one night, and that's enough to measure the mass of Jupiter. It's pretty amazing. We actually took images over several nights, but one night was actually enough. So I'm looking at Jupiter right now out my window. It's pretty bright. I think I do see Saturn beside it, actually. Saturn is to the right of it. I don't know if anyone else can see it. It's beautiful. It's really beautiful. It's amazing how close they are. I've never seen a conjunction that close before. So, somebody's asking how the software works. So which software are you asking? To operate the telescope, I'm using at least 5 different pieces. No, let's see, I've got, yes, 5 different pieces of software open. One of them is the Focus app, but I guess that one isn't really, and then the other one's the Weather app. So maybe 4. Okay, 4 pieces of software right now. So this camera that we're using is a color camera, and it's a really fast camera. So the main camera that we use for science and for imaging is a very sensitive camera, but it's got a huge field of view, and it's a beautiful camera, but it doesn't shoot in color. So I guess you can't really see color anyway right now. But this was a better camera for doing these kinds of events. And it's a color camera, so then you can see the color image immediately instead of having to process it later. And this is the software that we use to control it. So it's called SharpCat. It's a really nice piece of software, and it's not very expensive. And so, yeah, it's a pretty nice piece of software. It does, one thing that's nice about it is that it does dark subtraction and flat correction on the fly, so that you can, if you're taking a look at, say, galaxies or a nebula or something, it will correct the image on the fly, and it will, like, you take lots of exposures and it'll stack them on the fly, like combine them all together on the fly, which is kind of nice. So it's nice for events like this, so I don't have to like go away and try to process it and then come back with it. It just does it right away. Pretty cool. Oh, good. So some people are saying that they're able to see Jupiter and Saturn from where they are. Yeah, the sky is actually quite a bit clearer now. I don't know if anyone else sees it from their location, but from Vancouver, it's starting to clear up, and there's a pretty good view of Jupiter and Saturn from my window. It's fun to be able to do this event, to do this live stream from the observatory and be able to look out my window and to see it. I'm really thankful that I have a southern view.
Wow, that's really cool. Like for me, I'm facing the east, so like I can only look at the moon, but not the planets.
So Abby, if you like, feel free to just step out your door for a minute to go see it if you want. All of you,
Yeah.
really, feel free to go step out your door if you don't have a southern view. Yeah, I was planning, once these planets got too low, I was planning to see a few other things in the sky, but we could just, I don't know if anybody is interested in seeing something else. We've been looking at Jupiter and Saturn for a while. Oh, good. So people can see from Salt Spring, Maple Ridge. It's very cool to be able to see this. It's cool because it's like, it really is a once in a lifetime kind of thing. And you know what? Yesterday it was the closest approach, right? And the weather was terrible, so we couldn't do anything. But yesterday it was about 1/10 of a degree. Right now it's like 0.1 degree, right? Right now it's like 0.13 degrees. So it's not a huge difference from yesterday. So we haven't really missed out. Like you wouldn't be able to tell the difference by eye. From here in the camera, so Saturn is here right now. Saturn may have been like over here yesterday. So it's not a huge difference. So thankfully we had good weather today, even if yesterday we couldn't have good weather. Okay, so Jupiter, I'm so glad the sky cleared up and we were able to see Jupiter and Saturn. How about tomorrow? So they will still be very close, but it will be a bit more, let's see, how far, let me actually look on Stellarium. I'm actually using, I don't want to disturb the Sky X right now, but tomorrow Saturn will be too far to fit in this camera. So, but it'll still be close. Like it'll be probably about, like, let's see, if I move this over, there's Saturn. Saturn would probably be about there tomorrow. I don't know if you can see my mouse.
I think it's about 16, or make it minutes tomorrow. It was 6 yesterday, 10 today, and then 16 tomorrow.
18 tomorrow?
16.
16 tomorrow.
So still very close.
Yeah.
Not totally either.
Yeah. So it's still very close. So with your eyes, you could see them, and but with this camera, it'd probably be too far apart to see it with this camera. With our other camera, we could, but not this camera. Well, actually, we could. Actually, the truth is, we've cropped the view because the other side of the camera is pretty lousy, so we've cropped it. We could have actually, so the full view is this square, this rectangle. Right now, we're just showing the square because the other pixels are, I don't know, even flat corrections don't seem to help. Hey, what happened? Did I zoom? What happened? Zoom auto. Oh, I know why. We have now reached the limit of how low we can go with a telescope, and it's not going to track anymore. It stopped tracking. So that's why you're seeing Jupiter head towards the edge of the window, because it's setting. It's setting like the sun and moon set, right? Jupiter is setting. Bye-bye. Bye, Jupiter. It was so nice to see you. Okay. Well, let's see. How low did it go? Now we know how low we can actually see. It's about 10 degrees. Okay, so we cannot see Jupiter and Saturn anymore in our camera. That's all right. Okay, tracking is off now because we're too low. But you can see it with your eyes. I'm looking at it out my window right now, so please don't go to bed. Or please don't let 6 o'clock pass before you see with your own eyes. But for now, we could see something else. So we did see the moon earlier. I was thinking there's another planet out in the sky that is very cool. It is the planet Mars. So that's always a fun object because it truly is red. Okay, let's see if tracking re-engaged. So at least the Sky X controlled it. I've actually never run the telescope that low before. that was yeah, I hope I didn't. I hope that the tracking will re-engage without a problem.
So I just went out and saw it with my naked eye.
Oh, good.
And I saw the moon and Mars, and I've taken photos, and I'm going to try and share them.
Oh, good.
With my iPad, yeah.
Okay, so there is Mars, too bright. No, it's still too bright. Hey, look at that! It's a little bit of a gibbous phase. Actually, I only learned recently that Mars actually has phases like the Moon and Venus. Pretty neat. Look at that. Let me try to just zoom a little bit. So, the shorter the exposure, the better a better image we can get. So there it is. There's a phase. So I am going to zoom in a little bit so that we can see it. Zoom in this way, all right? There, I've zoomed in.
Wow.
It is a little blurry. Although, I wonder, I mean, the sky is pretty the atmosphere is pretty turbulent right now.
Yeah,
But
here's something like
the red planet.
pretty interesting about Mars. Because back in summer, I was told to write a story about how culture could have evolved on Mars. So I kind of took it in a more astronomical way, kind of discussing the different constellations and the pole stars and the types of sunset that you'll see on Mars. Because it's actually a little bit different from the Earth.
Yeah. Yeah, I remember when I was a kid, I memorized a bunch of facts about the planets. And one of them I remember is that the day on Mars is about the same length as the day on Earth, but the year is about twice as long. So you would just have to multiply your seasons by 2, but your day would basically be the same. We could like have the same sleep cycle.
That's a good thing.
Yeah.
And also, if you're on Mars, so on Earth, when you're looking at a sunset, you can see a lot of really orangey red color. However, on Mars, it's the reverse way. So a sunset on Mars would be bluish in color. So that's kind of something really interesting that's different from the Earth. Because in the Earth, normally, like during daytime, you would see a blue sky and a red sunset. And on Mars, you would see a red daytime and a blue sunset. So that's something interesting I found.
Yeah. Yeah, that's true. The sky is red on Mars. I mean, it's the same reason why the planet is red. From what I remember, is that it's because of oxidation. So the same thing that causes rust to be red is the same reason why Mars is red. And then the dust from the planet fills the atmosphere, which makes the atmosphere also look red. That's from what I remember.
Yeah.
I can't get Mars to look any sharper than this. Unfortunately. Mm-hmm. Yeah, Mars is definitely a target for future missions that with people. Oh, Xena, you had a great story. See, I don't know if you're still here, Xena, but you had a great story about Mars. Do you want to tell it?
Me? Like facts about Mars? Or
No.
like
Your own personal experience with
I'm
Mars.
sorry. I don't know if I'm allowed to say it online, but yeah, I actually signed up for the Mars one-way mission, but I didn't get any call.
Yeah, sorry
it's
about
actually
that.
interesting when you look at the application and what's the requirement, and one of the requirement is that you have to have a sense of humor, and you will be tested on you will be actually examined on your sense of humor. And I thought that was interesting.
Wow, but so they never actually gave you that test. Hey, it would be a fun test.
No, I would have liked to do that test. What is that sense of humor? I was kind of curious, like, what are they gonna bring in people who are not easy to, like, they don't have a good sense of humor, and you have to make them laugh? I wasn't sure.
You could tell them the planet joke I told you.
Oh yeah, yeah.
I'm
Or
kidding.
like practice knock jokes.
Even right, exactly.
Yeah.
I heard. I
There was
hadn't
only
heard
6
another really.
Canadians who got on the short list, actually.
Pardon me.
There was only 6 Canadians who got on that short
On
list.
the short list, yeah. Well,
Yeah, I think one was a teacher. There was also a doctor, and
yeah, that
I
makes
can't
sense.
remember what's the other one. I think there was one who was an engineer. So pretty interesting. And at that time when I applied, I just started my master's, so I was still in school, so
Yeah.
I didn't have a career yet. Maybe that's why they didn't take me.
Well, how many people applied to that? Do you know?
A lot. It's all over the world. People applied.
Oh yeah.
But I don't know the exact number. I just know that from the shortlist people, like I think there was on the website it showed like the shortlisted people, and I was curious how many people were picked from Canada, and there was only 6. And I was like, oh, okay, you know what?
Oh yeah, only 6. Well, I mean that's a pretty long short list though.
Yeah, and they're only, I think it's only 6 people who get to go on that. If they were to go through with that mission, there was only taking 6 people on that mission.
Right, right. Oh, that.
Yeah.
Oh, okay. I see. Okay. Well, that's actually quite a lot of people. Okay.
Yeah, sure.
So Mars, unfortunately, I don't know if it's because, you know what, I can just try, I'll try a bigger number to, maybe I'm going to regret this.
Joanna, there is
Yes.
a question on that about why the lack of, how the lack of weathering, or how weathering contributes to craters on both the Moon and Mars.
Oh, how the lack of weather contributes to craters on the Moon and Mars. Okay, the Mars does have weather, so but the Moon has zero atmosphere. So apparently, because like wind and rain and things on Earth, weather down rocks and things. So, but because there's no atmosphere on the Moon, a crater that you create will just stay there forever until another meteor hits it, right? But yeah, meteors stay there forever. So with Mars, I know like there are some craters in parts of the planet, and I'm not sure why they haven't been erased, but there are also craters on Earth that haven't been erased either from weather, like I guess the bigger ones. So Mars definitely does have a few craters, and it also has an atmosphere, so interestingly enough. Probably the smaller ones have been erased by weather, but there are a few bigger ones on Mars. Okay, should we move back to the Moon? Because the Moon's right by it, right there. Let's move back to the Moon. Maybe I can do better with the focus then. And then after that, if anybody else have any other requests. Wow, look at that.
Wow. I'm excited. That's the mountain.
Yeah, I think I haven't really had it that well in focus. Yeah, we should get it a little bit clearer than this. Nope. Yeah, so we saw the Moon earlier when there was cloud on top of Jupiter and Saturn, but now we can see it a little bit brighter. Okay, that's the wrong direction. Let's see. I'm trying to get it into better focus. Oh, there's something. Okay, let me do that again. Yeah, I've put it in the wrong direction. Apologies. I've made it worse. I'm sorry. Yeah, that's even worse. Oh, that's a little better. Okay, now I'm going to dip it down. Yeah, it's easier to see when it's darker, hey?
Yeah, it is.
Someone is asking, it's a good question, is asking, can you see the lunar rover? I don't think we can with our telescope, but it would be interesting if we can actually image it or focus on it one day.
Lunar, is there a lunar rover right there on the Moon right now? Is somebody aware of one? Because I am not aware of one on the Moon at the moment.
Oh, the only one I'm aware of is I think the Chinese one is still on the dark side.
Oh, the Chinese one. I see. Okay, yeah. I
Yeah.
thought that they had finished with that mission, but maybe not.
I don't know if it's a rover though. I think it might be some shared.
Joanna, there's a
lander.
couple of moon missions happening. There's the Artemis and the Lunar Gateway project, or not missions, but just some exciting things happening, right, in the world of space exploration.
Yeah, do you want to tell us about it?
Well, I do. The only thing I know is that there are 15 astronauts that they just announced, NASA or SpaceX or NASA, I guess, that they are going. That these are the astronauts that are going to be training for the Artemis mission, I believe. But I feel like Joshua Kutrick and Jenny Sidey-Gibbons, and there's some Canadian astronauts through the Canadian Space Agency that are also being considered. But I don't know all the details. But if anybody knows more.
So I do remember I read recently that Canadian astronauts have been selected to orbit the moon. Isn't that
Yeah. Right.
Did I read that correctly? I think I did.
Yeah. I think 5.
5 Canadian astronauts. Okay.
David St. Jacques, who was on the International Space Station, Joshua Kutrick, and Jenny Sidey-Gibbons, and I forget the other one.
Right. Okay. Well, that's cool. That'll be really exciting when that happens. I wonder when that's going to happen. Does anybody know?
I think 2024.
2024? Oh, wow. That's not too long from now. Okay. Cool. Okay, so we saw the moon twice already. I'm sorry, I haven't been able to get it to focus better than that. It should be more focused than that. But another thing we could take a look at, is it dark enough yet? It's probably dark. Pardon me?
Can we see Mars tonight?
Yeah, we did. We just looked at Mars just now. Should we do it again?
Sorry, I left the room for a minute because I had to.
Take a look.
I can't see. Yeah, I can't see the conjunction from my office, so I actually went outside to see it.
Yeah, it is. It's cool, hey? I can still see it from my window.
Yeah, great conditions for viewing tonight.
Yeah. Okay, so there's Mars again. I mean, I think, you know what? I think the focuser is actually not connected because it doesn't seem to be doing a whole lot. So we did fiddle with it earlier. I apologize. Because we had to change out the spectroscope for the camera, and then we had to refocus, and we thought we had it, but it seems like the focus isn't doing well. Yeah, it's not moving really. Okay, well, that's okay. We can kind of see it. Another what we could see actually is a more extended object. I was telling you about M31. It might even be dark enough for that. It's one of my favorite objects. I told you, one of my favorite objects in the universe. So, we only have a couple minutes left before it's time to go for dinner. But let's end with a galaxy that I hope will be visible. It's still considered twilight at the moment, at least astronomical twilight. So it may not be visible, but let's try it anyway. Okay, for this we're going to need a longer exposure. And we'll also need to bin. Yes, I know. Oh, and that's right, I'm going to have to select the different darks and flats. See if we can see anything. Oh, we have to wait for the oh, it's already there. Let me see. I have to, oh, I know what I wanted to do. Now I have to live stack. Hey, there's the Andromeda Galaxy. Okay, that's too far. And now I can see stars. Maybe that'll help me focus it a bit more. Actually, maybe it'll be better if I turn off the live stack. Yeah, so this is the Andromeda Galaxy, what you're looking at here. This is the galaxy I was telling you about, one of my favorite objects that you can actually see with your eyes. If you're in a dark site, if you're camping or something, you can see it with your eyes, and it's something like 2 million light years away. So it's just, when you look at it, you can think about how far those photons had to travel in order to get to us. It's pretty amazing to think of. Okay, well, we can end on that note. Okay, so this was the Andromeda with a little bit of processing here. I think it might be better this way. And yeah, the Andromeda Galaxy is the closest, it's the farthest thing that we can see with the naked eye, but it is the closest big galaxy to us. It is, it's kind of the Milky Way and the Andromeda Galaxy are the two biggest galaxies in the local group of galaxies, which includes about 40 to 60, depending on how you count the local group. And we are the two biggest galaxies, and eventually, in about 5 billion years or so, Andromeda and the Milky Way will collide and become a single galaxy. So that will be exciting if anybody is around to see it. But yeah, so let's end on this note, the Andromeda Galaxy. Thank you all for joining this Starry Nights. Unfortunately, there was a bit of cloud at the beginning, but it started to clear up and we still got to see the conjunction. It's still in the sky. I can see it out my window right now. So please, if you have a clear view to the southwest, don't forget to go outside and take a look. Binoculars might help. But I can see them. I wear glasses, but I can see Jupiter just to the right I can see Saturn just to the right of Jupiter. It's pretty striking, this pair of planets. So please do go step outside. And so thank you all for joining, and thank you to all the panel members who joined me today: Zena, Abby, Haley, Kyle, Scott, Ken, and Karambir. Thank you so much, and have a good evening.